Welcome to the data structure series. Today we are going to learn an important topic in data structure, list implementation using arrays. Before we jump into the C program, I want you to understand one important idea. What exactly do we mean by a list? We use lists everywhere in real life. For example, list of students, shopping list of marks, or even list of tasks. In data structure, a list is a collection of elements arranged in a particular sequence. Today we are going to see how we can represent such a list using an array, and more importantly how we can perform operations like insertion, deletion, searching, updating and retrieving elements. By the end of this session, you will be able to write these operations in C and understand their time complexity. Okay, let us start with the basic question: what is a list? A list is a linear collection of elements arranged in a sequence. For example, suppose I have 10, 20, 30, 40 and 50. Here 10 is the first element, 20 is the second element, 30 the third and so on. So every element has a position. Now remember this important point. In a list the order matters. So if I have 10, 20, 30, this list is different from a list that is having 30, 20 and 10. So a list is basically a sequence where elements have a meaningful position. Each element has a position, the order is very meaningful. Whereas in a set, order is not the defining feature. You can think about a classroom attendance list. If student A is at position 1 and student B is at position 2, changing their positions changes the order of a list. Yes. Moving on, let us talk about what an ADT is. ADT stands for Abstract Data Type. The easiest way to understand ADT is this. ADT tells us what operations we can perform, but it does not tell how these operations are implemented. For example, for a list, we may want to insert, delete, search, retrieve, update, and display the elements. These are the operations of a list ADT. But how do we implement these operations? We could use an array or a linked list. So the list ADT is like a specification or contract. It says these are the things my list should be able to do. The actual implementation comes later. ADT focuses on what? Implementation focuses on how. So now, why using an array? Yes, this is again a very important question. Why I use an array? Suppose our list contains elements 10, 20, 30, 40 and 50. We can store these elements inside consecutive array locations. The beautiful thing about an array is that every element has an index. For example, if 10 is at index 0, 20 is at index 1, I can directly access any element using its index. Suppose I ask for the element at index 3, I don't have to start from the beginning. I can directly access it. That is why retrieving an element using an array index takes order of 1 time. So array-based lists are very simple and they provide fast direct access. But there is a catch. What happens if I want to insert something in the middle? We'll be going to talk about that. So here is a small core code where it says hash define max 100 int list of max. So this max is the maximum capacity of the list here, and I have size set to 0 where size represents the current number of elements inside the list. For example, in the list 10, 20, 30, 40 and 50, the size is 5. Done. Every data structure has its own advantages and disadvantages. First, the advantages of implementing a list using an array is that it is very simple. You can directly access using an index, so retrieval and update are very fast. Traversal is also straightforward because you can simply use a loop and traverse. And there is a very little extra memory overhead associated. Looking at the limitations, the array has a fixed capacity. For example, if max is 100, we cannot store the 101st element unless we use another strategy. The second problem is insertion. Suppose you have 10, 20, 30, 40 and I want to insert 25 between 20 and 30. I cannot simply put 25 there because 30 and 40 are already occupying positions. So we need to shift elements. Deletion also has the similar problem. So remember, array has faster access, but insertion and deletion may require a lot of shifting. Now, let's perform our first major operation, insertion. I assume the list is 10, 20, 30, 40 and 50. I want to insert 25 at position 2. What should happen? We cannot directly place 25 at position 2 because 30 is already there. So first, we move the elements from the end towards the insertion position. 50 moves one position right. 40 moves one position right. 30 moves one position right. Now position 2 is free. So you put 25 there. So the final list becomes 10, 20, 25, 30, 40, 50. Now look at the C code. First, you check whether the array is full. If size equals max, we have list overflow. Next, you check whether the position is valid. Then comes the important loop. For I is equal to size minus 1, I greater than or equal to position I minus minus. Notice that you move from right to left. Why? Because if we start from the left, we might overwrite values before moving them. So after shifting, you execute list of position is equal to element, meaning that you are placing 25 into that position, and finally you increment size because the number of elements has increased by 1. This operation can take order of n time because in the worst case, we may have to shift many elements. Done? Moving on, let's do the opposite, the deletion. Suppose the list again contains 10, 20, 30, 40 and 50. Suppose I want to delete the element at position 2. That means 30 has to be removed. But now we have an empty space. So what do? We shift the elements after it towards the left. 40 into the position of 30, 50 into the position of 40. So the final list becomes 10, 20, 40 and 50. Look at the for loop. For I equal to position I less than size minus 1 I plus plus. So here we are moving from left to right. Why? Because during deletion we want the next element to move into the current position. Before deletion we also check whether the list is empty. If size is 0, you cannot delete anything. It means list underflow. Finally, you decrease the size using size minus minus. Again, deletion can take order of n time because shifting is required. Now let's look at two very easy operations, the update and retrieve. First, update. Suppose the list contains 10, 20, 30, 40 and I want to change 30 to 35. If 30 is at position 2, I simply write list of 2 is equal to 35. That's it. There is no shifting. So update takes only order of 1 time. It's simple. I just put the new value into that particular position. Now retrieve. Suppose I ask what is the element at position 2? I can directly access list of 2 and get the value. Again, retrieve also takes order of 1. So this is one of the biggest advantage of an array. Direct index access means order of 1. Fine. Now suppose I don't know the position of an element. What should I do? I should search. I only know that I want to find 40. Can we access it directly? No, because we don't know its index. So we need to start from the beginning. Compare 10 with 40, not equal. Compare 20, not equal. Compare 30, not equal. Compare 40. If it is found, done. This is just a linear search. Our loop checks every element one by one. The important point is that search may have to examine the entire list, therefore the time complexity becomes order of n. In the best case, if the element happens to be the first element, it can finish immediately. Fine. But in the worst case, we may need to check every element. So it is definitely order of n. If the list contains 100 elements and maybe the element we are searching for is at the last position approximately, how many comparisons might we need to do? Of course, 100 comparisons. The next operation is display, also called the traversal. Traversal means visiting every element in the list. So you start from index 0 and continue until the index is size -1. For example, 10, 20, 30, 40, and 50, the loop starts with I equal to 0 and continues while I is less than size. So for every position, we print the element. So the output will be like 10, 20, 30, 40, and 50. Because you visit every element, display takes order of n time. One important thing we check before traversal is whether the list is empty. If size is 0, you simply display list is empty. So let's pause here and connect everything. We have now seen the major operations of an array-based list. Create means creating an empty list. Fine. Insert means adding an element. Delete means removing an element. Update means changing an existing value. Retrieve means getting a value using its position. Search means finding an element. Display means visiting all the elements and displaying them. Now notice something very interesting. Insert and delete involve shifting. Update and retrieve don't. Search also involves scanning. Display involves visiting every element. So now once you understand these ideas, you don't have to memorize the programs blindly. You can actually derive the code from the operation. Now let's compare the time complexities. Insert order of n. Why? Because elements may have to be shifted. Deletion order of n. Again because of shifting. Update is order of 1 because we directly access the index. Retrieve, it's order of n. Order of 1, again direct access. Search is order of n because we may need to check every element. Display is order of n because we visit every element. So here is a very easy way to remember. Direct index access, order of 1. Scanning or shifting, it's order of n. So this simple rule will help you understand many array-based algorithms. Before we finish, let us do a small recap. What is the role of size? It tells us how many valid elements are currently present in the list. And finally, which operations are order of n? Insert, delete, search, and display. Done. Why insertion requires shifting? Because I cannot directly put an element into a position because it will override. So we need to shift and then insert an element. So the key takeaway here is that an array gives fast index access, but insertion and deletion are quite expensive because elements need shifting, especially if the array size is large. Any doubts? Post it in the comment section. I'll be happy to answer. Thank you. Happy learning.